Welcome to the Uranium Unleashed podcast.
Thanks for having me. It's great to be here.
I am so excited for this one because we are bringing you a custom-tailored deep dive today into a truly historic supply-side shock that is just, well, it's unfolding right now in the global energy markets.
Yeah, and it's something that really hasn't happened in a generation.
Exactly. For the first time in over 2 decades, you have two major, fully financed uranium mines simultaneously breaking ground in Canada's Athabasca Basin.
Which is just a monumental shift. I mean, you have a region that historically supplies, about 20% of the world's uranium?
Right.
And it's basically waking up from this 20-year development slumber to try and save a global power grid that is suddenly, desperate for baseload energy.
Desperate is the word. And to figure out how we actually got here and the exact mechanics of how these two massive projects will operate, I've got a really phenomenal stack of sources in front of us.
Oh, yeah. The data we're looking at today is incredible.
It really is. We are pulling from official regulatory filings from the Canadian Nuclear Safety Commission, the CNSC. We also have corporate announcements from NexGen Energy and Denison Mines.
Plus some really deep market analyses, right?
Right. We've got Sprott's Uranium Outlook 2026, the World Nuclear Association's 2025 Fuel Report, and this incredibly comprehensive March 31st, 2026 investment thesis report on Saskatchewan's whole generational construction surge. Okay, let's unpack this.
So to really understand the gravity of these two new mines breaking ground, we first have to look at the macro environment. We have to look at a world that is essentially starving for primary uranium supply.
Starving almost feels like, an understatement when you look at the WNA's 2025 fuel report.
Oh, the numbers there are staggering.
Totally. They are projecting that global reactor demand for uranium will rise 28% by 2030. And we're not starting from a low baseline either.
No, not at all.
In 2025, requirements already hit roughly 68,920 tons. The demand for reactor fuel is just exploding.
And it's not just driven by traditional grid needs anymore. You have this massive, ravenous new appetite from AI data centers that absolutely require, 247 carbon-free baseload power.
Because wind and solar they simply cannot provide the 90+% capacity factor that a gigawatt scale server farm demands, right?
Exactly. And if we connect this to the bigger picture, that explosion in demand is colliding with a really severe structural deficit on the supply side.
The WNA explicitly warns about this, don't they?
Yeah, they warn that existing high-grade mine output is projected to actually halve between 2030 and 2040. Decades of chronic underinvestment in mining after Fukushima mean the world is quite literally running out of primary supply.
Because you can't just, flip a switch and turn on a uranium mine tomorrow.
Right. It takes 10 to 15 years of permitting and development.
So it's kind of like imagine the global uranium supply as a town's water reservoir. And we've just opened the drain way wider for all these AI data centers and new nuclear plants.
Yeah, water's rushing out.
But at the exact same time, the main river feeding the reservoir is just drying up because our legacy mines are depleting.
That's a great analogy. And what I find really fascinating in the Sprott 2026 outlook is how the buyers are reacting to this drying reservoir. Or, well, in the case of Western utilities, how they are failing to react.
Right, because utilities have historically really lagged in their long-term contracting cycles.
Yeah, they've been kind of lulled into complacency by a decade of really cheap spot prices.
And while the utilities were just sort of asleep at the wheel, financial buyers stepped in.
Precisely. Funds like the Sprott Physical Uranium Trust aren't just buying paper contracts, they are scooping up millions of pounds of physical uranium.
Literally putting it into drums and locking it away in vaults.
Treating it as a strategic, sequestered financial asset. And every single pound Sprott buys is a pound permanently removed from the spot market.
Which drastically tightens the floating supply available to the actual power plants. Which honestly exposes the terrifying vulnerability of the United States right now.
Oh, the U.S. situation is precarious.
They operate the largest fleet of nuclear reactors in the world. They require nearly 50 million pounds of uranium every single year just to keep the lights on. But our sources say the U.S. currently controls less than 1% of global enrichment capacity.
Less than 1%.
And in the third quarter of 2025, they mined a mere 329,623 pounds domestically. I mean, that is just a rounding error.
It is a massive strategic liability. It leaves the U.S. grid highly dependent on foreign suppliers, particularly nations like Kazakhstan and Uzbekistan.
Right at a time when energy security is like the paramount geopolitical imperative.
Exactly, especially with stringent new restrictions on Russian uranium imports looming for 2028. You cannot run a localized tech economy on a fuel supply chain that relies on geopolitical adversaries.
So the Western world desperately needs new, reliable, massive sources of uranium located in friendly jurisdictions. Which brings us to the first of the two projects breaking ground in Saskatchewan.
The brute force solution to the macro deficit.
NexGen Energy's Rook I project.
Yeah, Rook I is an absolute behemoth of an engineering undertaking. It's located in the southwestern area of the Athabasca Basin, centered around the Arrow deposit.
And the Arrow deposit isn't just large, it is officially the world's largest undeveloped high-grade uranium deposit. The scale here is kind of hard to wrap your head around. It features 240 million pounds of probable reserves.
240 million pounds. But it's the grade that is truly exceptional, 2.37%.
To give you some context on why that matters, the global average for a traditional open-pit uranium mine is usually somewhere between 0.05% and 0.1%.
Right, so let's translate what that grade actually means underground. When you are mining at 0.05%, you have to move literal mountains of barren rock to extract a single pound of yellowcake.
Which means your energy expenditure, your fleet of diesel trucks, your milling chemicals, it's all massively inflated.
Exactly. But at 2.37%, you're dealing with rock that is exponentially more concentrated. That grade places Rook I in a very narrow elite class of global deposits.
Deposits that boast margins robust enough to justify the massive capital costs of underground shaft sinking, regardless of where we happen to be in the uranium price cycle.
Yep. And after years of waiting, the regulatory hurdles have finally been cleared.
Yeah, on March 5, 2026, the CNSC issued the final federal license to prepare, site, and construct for Rook I. Official construction starts in the summer of 2026.
And this is a staggering capital deployment.
Oh, absolutely. It's a 4-year load with a capital cost of 2.2 billion Canadian dollars. But at nameplate capacity, Rook I is designed to produce up to 30 million pounds of uranium annually.
What's fascinating here is the sheer market dominance that 30 million pounds represents. Think about the global deficit we just outlined. That single project will account for over 20% of the current global supply.
20% from one mine, that's crazy.
It represents more than 50% of all Western world uranium production. Rook I alone will match or even exceed the combined output of Cameco's existing McArthur River and Cigar Lake mines.
And those two are basically the titans that have anchored Western utility fuel chains for the last 20 years.
Exactly. NexGen CEO, Leigh Currier, was actually quoted in the corporate filings highlighting the unprecedented speed of this development. And he noted a frankly astonishing discovery cost of just 13 cents per pound.
Wow, 13 cents. But here's where it gets really interesting. If Rook I is basically this massive $2.2 billion industrial combine harvester, right, churning out 30 million pounds of uranium every single year starting around 2030,
Yeah.
who is actually going to absorb all of that? Doesn't injecting that much new, highly concentrated supply risk, crashing the very spot price, which is currently sitting around $83 a pound, that makes a $2.2 billion mine economically viable in the first place.
Well, it's the classic paradox of commodity markets, right? The cure for high prices is high prices.
Right.
But in this specific scenario, the structural deficit is so profound that the market doesn't just want Rook I. It absolutely needs it just to tread water.
Because of the depleting legacy mines.
Remember, the WNA forecast. Existing Western mine output is projected to fall materially right around the exact time Rook I hits its nameplate capacity.
Oh, the timing is almost perfect.
Yeah. When you factor in the baseline demand from the global reactor fleet, plus the new sovereign contracting waves, that 30 million pounds is practically spoken for before it even leaves the ground.
So you're saying the real challenge for NexGen isn't price compression at all?
No, it's execution.
You mean actually surviving a 4-year underground construction process in the remote Canadian North?
Exactly. Sinking deep shafts in the Athabasca Basin geology is notoriously difficult. The region is famous for massive high-pressure water inflows.
Right, it's not a walk in the park.
So while the economics make sense on paper, moving from a CNSC license to a producing underground mine is a brutal, capital-intensive gauntlet.
Which naturally brings us to the second project, breaking the 20-year development drought in Saskatchewan.
Yeah.
Because if Rook I is the heavy machinery, the brute force approach to moving rock, Denison Mines' Phoenix project is basically the high-tech laser scalpel.
The contrast between the two engineering approaches couldn't be starker.
No, it's day and night. Denison's Phoenix project is located at the Wheeler River property over on the eastern side of the Athabasca Basin.
And while Rook I is the largest undeveloped high-grade deposit, Phoenix boasts the title of the world's highest-grade undeveloped uranium deposit.
We are talking about an eye-watering 19.13% U3O8 grade. That is roughly 8 times the grade of the Arrow deposit at Rook I.
8 times. It is some of the most highly concentrated uranium mineralization ever measured on the planet. And rock that hot is entirely different to handle.
And because that grade is so extreme, and because of the specific geometry and shallow depth of the deposit, Denison made a really radical pivot.
They opted entirely against traditional underground digging. No shafts, no miners blasting rock at the ore face.
None of that. Instead, they're using a technology called In-Situ Recovery, or ISR. Let's break down the mechanics of ISR, because on its face, it sounds a little like science fiction.
It does, yeah.
Think of it like a massive underground espresso machine.
I like that.
Instead of digging out the coffee grounds, the ore, and bringing them to the surface to brew, you leave the rock exactly where it is.
Right, you drill a highly precise grid of injection and recovery wells.
Yeah. Then you pump a specially formulated acidic solution down into the ore body. The acid dissolves the uranium right there within the host rock.
And finally, you just pump that pregnant uranium-bearing liquid back up to the surface for processing into yellowcake.
Exactly. It's wild.
That espresso analogy is highly accurate. You are forcing a liquid through a packed solid to extract the valuable commodity without moving the surrounding earth,
which avoids large-scale underground excavation entirely.
It drastically reduces the surface footprint and tailings generation, and crucially, the capital expenditures are a fraction of traditional mining.
But hold on, you can't just pump acid into the bedrock of one of Canada's most pristine environments and hope for the best, right?
No, definitely not.
How do they prevent that highly acidic radioactive solution from just migrating outward and contaminating the surrounding groundwater?
This raises an important question, and it's where Denison is introducing a true first-of-its-kind technological leap.
The freeze wall.
Yes. To contain the ISR solution in the specific geology of the Athabasca Basin, they are deploying an artificial ground freezing perimeter.
Right.
They will drill vertical freeze wells in a massive ring around the entire deposit, sinking them all the way down into the impermeable basement rock.
And then they pump a commercial coolant through those sealed pipes to constantly strip heat away from the earth.
Which, over months, literally freezes the groundwater in the rock pores.
Wait. You're telling me they were relying on an active subterranean refrigeration system to create a 10-meter-thick frozen ice wall deep underground? Yeah. And then they are going to melt the uranium out of the rock inside that giant ice cube. That sounds incredibly prone to failure.
It sounds risky, sure.
Like, what happens if there's a supply chain issue with the coolant or a massive power failure at the site? Does the wall just melt and release the acid into the environment?
Well, the engineering actually accounts for that through thermal inertia. A 10-meter-thick wall of subterranean ice in northern Canada doesn't just melt overnight.
I guess that's true.
Even if you completely lost power to the chiller plants, it would take months for the wall to thaw enough to permit any sort of hydraulic breach.
Okay, that makes more sense.
But you are absolutely right to point out the ambition of this design. ISR is used commercially at a massive scale in places like Kazakhstan and the U.S.
But never in Canada, right?
Right. It has never been applied commercially in Canada's basement-hosted, extremely high-grade geological setting.
But the regulators have totally bought into the science. Denison received its CNSC license in February 2026. The board made the final investment decision on February 24th, and construction actually commenced in March 2026.
And because it's an ISR project, the build is much faster and cheaper than Rook I.
Way cheaper. We were looking at a 2-year build costing an estimated $600 million US. They are targeting first production by mid-2028 at an initial capacity of 2.4 million pounds annually.
Denison's CEO, David Cates, didn't mince words in the press release either. He called it the beginning of a new era and noted that it positions them as a key global supplier well before the end of the decade.
So we have two completely divergent engineering philosophies. You've got NexGen's traditional multi-billion-dollar underground shaft mine.
And Denison's surgical high-tech freeze-wall ISR operation.
Right. Both are fully financed, both are licensed, and both are breaking ground simultaneously. It is genuinely a generational shift for the Athabasca Basin.
But with a generational shift comes a generational reality check on risk. We have talked about the macro deficit, and we have explored the incredible engineering behind these two solutions.
Yeah.
Now, we have to look at the severe real-world obstacles standing in the way before a single pound of this uranium ever makes it to a utilities fuel buyer.
So let's talk risks.
The baseline risk is purely financial. Both of these projects, despite their amazing high grades, require uranium prices to stay well above $65 a pound to justify their massive capital deployments.
And to generate acceptable internal rates of return.
Right. And while the current spot price is floating around $83, commodity markets are inherently volatile.
And a large part of what is keeping that spot price at $83 right now is a geopolitical risk premium.
Oh, heavily.
Our sources specifically point to the April 6 Iran deadline binary and the ongoing conflicts that have disrupted global energy supply chains.
The market is currently pricing in the threat of a major geopolitical disruption.
And that is a double-edged sword, isn't it? If that April 6 binary resolves cleanly, or if broader geopolitical tensions just unexpectedly ease, that risk premium could evaporate overnight.
And the spot price could soften materially, which rapidly tightens the operating margins for a $2.2 billion underground build like Rook I.
And we haven't even touched on the sheer execution risk of the builds themselves.
Sinking deep shafts in fractured water-bearing rock for Rook I.
Attempting a novel, commercial-scale freeze-wall ISR process in unprecedented grades for Phoenix.
Exactly. Both of these companies are operating in remote northern locations where complex logistics, severe weather, cost overruns, and schedule delays are practically a rite of passage for the mining industry.
And beyond the engineering and the market pricing, there is a critical social and legal reality that cannot be ignored here: indigenous consultation risk.
Very true.
Both of these projects operate on traditional lands, and they require delicate, ongoing, and meaningful community partnerships. And the sources show us exactly how quickly that can become an existential roadblock.
Right. The March 31st, 2026 investment thesis report explicitly highlights a major legal development on that front.
Yeah, the Métis Nation-Saskatchewan formally filed a judicial review against Paladin Energy's Patterson Lake South project.
They are seeking to legally set aside the federal minister's environmental approval and impose an injunction to halt the project entirely.
It is a vital, real-time reminder to the market that receiving a regulatory green light from the CNSC does not grant you immunity from legal challenges.
Establishing and maintaining true alignment with local Indigenous communities isn't just an ESG box to check on a corporate presentation. It is a fundamental, structural requirement for operating in the basin.
Because without it, your timeline just goes to zero.
Completely to zero.
So what does this all mean? If you are tracking this market, you really need to understand the layers of complexity here. You aren't just betting on the macro thesis that the world needs more nuclear energy.
No, you are betting on the thermodynamics of complex underground freezing technologies working perfectly.
You are betting on multi-billion-dollar shaft-sinking operations, staying on budget.
Betting on geopolitical risk premiums holding steady.
And you are betting on mining companies successfully navigating incredibly delicate community relations and legal frameworks. And you need all of those bets to hit simultaneously.
It requires an extraordinary synthesis of geology, heavy engineering, high finance, and nuanced diplomacy.
It really does. To quickly recap where we stand, the world is facing a devastating structural uranium supply deficit right as a global nuclear renaissance begins.
Fueled by decarbonization mandates and the massive non-negotiable baseload power needs of AI data centers.
But Saskatchewan is finally answering the call. They are breaking a 20-year development drought with two monumental, highly contrasting projects: NexGen's massive 30 million pound a year Rook I,
and Denison's highly targeted technological marvel at Phoenix.
Yet, there's one final lingering implication buried in these sources that we haven't fully addressed yet.
Yeah, we've talked extensively about who will buy this uranium, and the sources heavily highlight an ongoing sovereign contracting wave.
Right. We are seeing nation-states act aggressively to secure their long-term energy sovereignty, and they're completely bypassing traditional market mechanisms to do it.
India is actively locking up supply from existing global producers. China is aggressively targeting an astonishing 110 gigawatts of electrical capacity by 2030.
And to fuel that, China alone will require roughly 22,000 tons of uranium every single year.
Exactly. So here's the provocative thought I want to leave you with today. We have spent this entire time analyzing these 32.4 million pounds of new Canadian uranium coming online.
Right.
But what if that supply never reaches the open market or Western utilities?
Oh, wow.
What if sovereign, state-backed buyers who are acting on national security imperatives rather than strictly market economics step in and swallow this entire generational supply surge in long-term off-market contracts before the first ounce of yellowcake is even produced?
That would mean the biggest uranium supply shock in 20 years happens right in North America's own backyard, and Western utilities are still left entirely out in the cold.
Exactly.
That is a fascinating and frankly terrifying dynamic to consider for the domestic grid. Thank you so much for joining us as we explored these sources and unpacked the complex realities of the Athabasca Basin today. Keep a very close eye on Saskatchewan. The next few years are going to be absolutely critical for the future of the global energy grid.